Good morning, everyone. I hope you all are doing fine. And guess what? We are going to continue our session on steps of research. And today we're going to talk about how to conduct sample, right? How to collect sample, how to test it, and also we'll also talk about error in sampling, which is quite important because in exam you are always get at least one or two questions based on sampling. So it's in that perspective this particular topic becomes more important that you should pay attention. So shall we start? Let me tell you what is sampling, right? Imagine you're at a party and you want to know if everyone likes the music, right? It's a big party, so you can't just ask everyone, right? Then what do? You ask a few people. That's sampling. And in research, sampling is just like that. You pick a smaller group from a big bunch of people or things to understand them better. Since checking in with everyone is often impossible, like too many people or too little time, right? You select a smaller group which can give you a good idea of what the whole crowd thinks or feel. Right, let me tell you about the population first. It's quite important in sampling. So, in research, we call it the population. It's not just the people, it could be anything. It could be animals, plants, countries, chocolates, or you name it. If you want to study it, that's your population. Think of it like this. If you are curious about what all students in your school think about the new cafeteria menu, then all the students are your population. But asking each one, that's a kind of big task, right? So you need a shortcut for that, and that's where this sampling comes in. Okay, let's see another example. Like the entire student body at a university is an example of a population, right? And it would include all students enrolled in that school at the time of the data collection. This whole set of data would be your population. And from that you take sample, right? Now let's talk about the sample. Now we understood what is population, right? And in research, this smaller group is what we call a sample. It's like taking a quick peek into a bag of jelly beans to guess the flavors in the whole bag, right? If your school has 1000 students, you decide to ask 100 of them about the cafeteria food. Those 100 students is what your sample. So the trick is to pick a sample that gives you a good picture of everyone's opinion without having to ask every single person, right? And imagine you're trying to survey every student in a university, right? Every tree in a forest or every star in the sky. It's tough, right? You cannot do that. That's why we have sample. And it's practical, it saves time, and it still gives us a good idea of what the whole group thinks or experiences, right? Plus, with some neat math tricks, we can make pretty accurate guesses about the whole population based on our sample. So remember, in research, population is the whole group you're interested in, and sample is the smaller group you actually study. So sampling is picking that smaller group to understand the bigger one. Think of it as a shortcut to learning about a whole bunch of things or people without the need to check each one. It's a bit like reading a summary instead of a whole book. That saves time and still gives you the main idea. Let me tell you another example. If a researcher is conducting research on students opinion at a university with a population of 1000 students, right? What he could survey a sample of just 100 students. So that's your sample here, guys, right? And in sampling we also have like two types. Main is probability sampling and then is non-probable sampling. In probability sampling we have also some types that we're gonna talk about, right? So let me tell you the types of sampling methods, right? So remember, as I told you, we have two sampling method. One is probability sampling and another is non-probability sampling. So you might be wondering, what is probability sampling? Well, imagine you have got a big group like everyone in your school, and you want to know what they think of or how they behave, but checking with everyone is a huge task, right? And that's where probability sampling comes into play. It's like a picking name out of hat, but in a smarter way. Here's the thing, in probability sampling, everyone in your group, like all the students in your school, has a chance to be picked for your survey or study, right? And the cool part is you can figure out exactly what the chance is. This helps because when you pick people randomly and know their odds of being picked, you can make some pretty good guesses about the whole group. And think of it as a fair game. Everyone has a shot and no one is left out on a purpose, right? This way, when you look at your sample, the people you picked, you are really getting a mini version of your whole group. Right, so that is your probability sampling. And in probability sampling, we have like 6 types. First is like simple random sampling, then systematic, stratified, probability, or size sampling, and cluster sampling, multi-stage sampling. Right, and on the other hand, in non-probability sampling, we have like 8 types, that starting with quota sampling, convenience sampling, voluntary, purposive, snowball. So in previous exam they have asked question based on snowball sampling, and it was important because continuously in like 3 years they have been asking about this snowball sampling. And then also we have like minimax, then line-intercept sampling, and at the end we have panel sampling. And we'll all talk about all these types one by one, right? So as I told you, probability sampling is what? It's a random selection ensure strong statistical group inference. The first one we're going to talk about simple random sampling. Like everyone got an equal shot. Now let's zoom into specific type. Simple random sampling. So picture this. You have a big jar with the name of every student in your school. If you reach in and pick a name, that's simple random sampling, right? Each person has the same chance of being picked, which is totally fair and square. Right. And how do you do this? You could use a random number generated or even old school methods like drawing your names from a hat. For example, think about your school having 250 students and you need to know what they think about the new cafeteria menu. You can't ask everyone, right? So you decide to randomly pick 25 students. You write down everyone's name on slip or paper, toss them into a jar and draw 25 names, right? And those 25 names are your sample and mini version of your school representing everyone's thoughts, right? So that is your simple random sampling. Very simple, right, to understand. And for another example, you can see out of 250 employees, 25 names are drawn from a hat. In this way, the population is all 250 employees, right? And the sample is random because each and every employee has an equal chance of being chosen, right? Next, we have systematic sampling or interval sampling. Very important because in exam they ask question, they already asked about it. So in that perspective, again, this particular sampling becomes more important. So imagine you're in a library looking for books to read. Instead of picking any book randomly, you decide to select every fifth book on the shelf. Right, that's basically what systematic sampling is. Let's say we are at a company and we need to survey some employees. First, we line everyone up in a list, maybe alphabetically or whatever, right? To keep it fair, we don't start at the first person, right? We pick a random starting point, say the fifth person in the list. And from that, we also pick like every 10th person, like 5, 15, 25, 35, and so on until we have the number of people we need, like 100 we need, right? It's like picking every 10th jelly beans from a jar until you have enough for your sample. So guys, that's your systematic sampling. Very easy to understand. Then we have a stratified sampling, which is like the most important sampling that you should understand, because in exam they have asked like every shift about stratified sampling. So in that case, again, this sampling is your thing to understand. Anyway, let me tell you, Imagine you're at a huge party, right? That's your population, and you want to know what kind of music everyone likes, right? But here's the catch: not everyone is into the same tune, right? They could be, interested in something else. So what we gotta be smart about this. This is where stratified sampling comes in as a DJ, right? Identify the group, and that group is defined at strata, and this that's why it's called stratified sampling, right? First we decide the crowd into smaller groups based on what we are interested in. Say we have got the pop lovers, then rock lovers, and other types of music. So these groups are your strata. So the idea is to recognize the different vibes in the room. So this way we don't end up asking only the rockers or other genre and miss out on the pop lovers. So we get a more accurate playlist that reflects everyone's taste, not just one, but it represents everyone, right? And now we don't have time to ask everyone, right? So in each group we randomly pick a few people and ask their favorite tracks. This is like taking a sneak peek into each group without needing to survey everyone. Let's say there are 100 rock lovers but only 50 EDM fans, right? If we pick 10 from each, we are giving equal weight to both groups even though they are different in size. This helps us to balance things out and not let one group's preference overpower the other. This part about numbers, we decide what fraction of each group to ask. Like let's ask 10% of each music genre group. This fraction helps keep things fair and square, right? And let me give you another example, right? Like picture a company with 500 women and 300 men. We want to understand their views on a new policy. To keep it fair, we sort them into two groups based on gender, and then maybe we decide to ask 10% from each group. That means we survey 50 women and 30 men. This way we get a good mix of opinion without surveying all 800 or 500 people, right? So that's your stratified sampling. Next we have probability proportional to size sampling, in simple word PPC. It's very important because they might ask question based on that also, right? So imagine you're in a room with groups of different size, right? One group has 20,000 people and another has 10,000 people, right? And now if you had to randomly pick one person from the entire room, the odds of picking someone from the smaller group are actually higher, right? Why? Because we are giving each group an equal chance. It's like saying each group, no matter its size, gets one lottery ticket. So in that 20,000 group, your chance of being lucky one is like 0.005%, right? But in the 10,000 group, your chance of doubles to like 0.101, right? And this method is great when you have subgroups of different sizes and you want to give smaller groups a fair shot at being represented, right? So that was your PPC sampling. Next we have cluster sampling, right? Imagine our population is a big pizza cut into slices, right? Each slice should be mini version of the whole pizza. Instead of picking random individuals from the entire pizza, we pick a few slices and focus on them. This is often done when it's too hard or expensive to sample everyone, right? For example, let's say we want to survey household in a city, right? Our city is huge, right? And surveying every house is a kind of mammoth task. What do we do instead is randomly pick, right? Say 100 city blocks. Right. These blocks are our clusters. Then we go all in and interview every household in these blocks. It's like choosing a few pieces of the pizza and eating every bit of them. Another example, imagine a company with office in 10 different cities, and it's not feasible to go, every office of your data collection. Right. So what we do is randomly choose 3 offices, and these offices are our clusters. We then focus our effort on collecting data from these selected offices, right? And this method saves times and resources, especially when dealing with large population spread over vast areas, right? By focusing on clusters, we can get a good snapshot of the whole without having to cover every single individual. And it's very important sampling because in exam they have asked question on cluster sampling also, right? So in a nutshell, that PPS gives smaller group or better chance of being represented, and on the other hand, cluster sampling helps us like manage big populations by breaking them down into more manageable subgroups. Both methods are about making sampling more practical and representative, especially when dealing with diverse and widespread population, right? Another sampling you can see here, multi-stage sampling. So this multi-stage sampling is like a more complex version of cluster sampling. Imagine you have a big group of items or people you want to learn about. This is your population, right? Now diving straight into this huge group can be overwhelming and expensive. That's where multi-stage sampling steps in to make your life kind of easier. And here's how it works. You start by splitting your big population into smaller groups. These groups are called clusters, right? They could be anything like different neighborhood in a city, or in the case of our example, areas code in a phone network. Now instead of trying to study everyone in every group, you pick a few of these clusters randomly, and this is your first stage of sampling. Think of it as picking a few slices of a big cake to taste instead of whole cake, and this step alone saves you a lot of time and effort. Next, within each chosen cluster, you go one level deeper. You randomly select even smaller units or individual, right? And continuing with our phone network example. Right. After selecting a few areas code, you then randomly pick some phone numbers within those areas code. And this sampling in stage, right? And first the cluster, then the smaller units, is the essence of multi-stage sampling. The beauty of this approach is that it's more manageable and way cheaper than trying to look at every single unit in your big population. You don't need to have a list of everyone or everything you're studying, just enough to represent a variety of the larger group. Right, so in summary, multi-stage sampling is a clever step-by-step approach to studying a larger population. By breaking down the process into more manageable chunks, it becomes a practical and cost-effective way to gather information. And this method is super useful, especially when dealing with a really large population where studying, everyone isn't easy, right? So that is your multi-stage sampling. Next, we'll talk about non-probability sampling. And in this session, we already talked about probability sampling, where we had like 6 types of sampling, right? And here is non-probability sampling. As I told you, sampling is divided into 2 major sampling types, right? Like probability and non-probability. We already talked probability sampling. Now we'll focus here on non-probability sampling. Let me tell you about this non-probability first, and then we'll move to its type, right? Picture this, you're picking a team for a game, but instead of drawing names from a hat, you're just choosing whoever is closest to you or those you like. And that's non-probability sampling, guys. You're not giving everyone an equal shot at being picked. Some people, like those not in your immediate circle or those you don't notice, won't even stand a chance, right? We call these folks out of coverage or undercovered because they are just not on our radar, right? And since you're not picking randomly, you can't really pin down the odds of someone getting selected. It's like trying to guess who will be picked for a school play without knowing the director's preferences. You're just making assumption about who should be on the team based on what you think you know everyone, right? And but here's the catch: because your selection isn't random, you can't be sure if your team really represents the whole class. It's like only listening to a few opinions and thinking they speak for everyone. This way of picking can lead to what we call exclusion bias, and that's a fancy term for accidentally leaving out certain viewpoints or types of people, which means your team might not really show the full picture of your class's talents or opinions. And the tricky part is when you try to say, like, hey, my team represent everyone in the class, right? And you might be way off because you only chose from a smaller specific group, right? And it's like assuming everyone love pizza, right? Just because your close friends do. So in a nutshell, non probability sampling is quick and easy, sure, but it's a big like taking a shortcut and missing out on the full diverse picture of the whole class. Right, now let's talk about its type. We'll begin with quota sampling, and think of this quota sampling like making a mini version of big group, ensuring it has all the key flavors. Imagine you have got a huge salad bowl representing everyone in a town. Right, and in quota sampling, you are not just grabbing a random handful of salad. Instead, what you're doing, you're making sure you get a bit of everything. Some lettuce, some tomatoes, cucumber, each representing different types of people in your town. For example, let's say you're told to find out what folks aged 45 to 60 think about a new park. In quota sampling, you might decide to chat with 300 women and 400 men in the age group. You're not picking them randomly, you're choosing them to make sure you get a balanced mix. Kind of like ensuring your mini salad has all the ingredients of the big, salad bowl. Next, we have convenience sampling, accidental sampling, opportunity sampling, grab sampling. These are all the same, but different name, because in exam they won't ask like convenience sampling, but they'll ask its different name like accidental sampling, opportunity sampling, and grab sampling. Let me tell you about this. It's all about what's easy to reach. Suppose you're a student curious about how many cans of Coke people drink on a Friday night in your school or in your college. You might just text a few friends or kind of swing by a party to ask around. Easy, right? But here's the catch, because you're only talking to people you can easily reach, right? Your findings might not represent everyone in your college, right? And it's like trying to understand what's is in the salad bowl by only looking at what's on the top. Sure, you'll get some insights, but they might not tell you the whole story. In both methods, it's crucial to remember that while they are great for getting a quick idea or a specific association, they might not always give you the full picture of what everyone thinks or does. They have their pros and cons, just like choosing between a quick snack or a full meal, right? That is all about your convenience sampling. Now we'll talk about voluntary response sampling. And again, think of it when you ask for volunteers to help out with something. In research, this is what we call simple voluntary sampling. And just like when you ask for volunteers for a class project, in voluntary sampling, people choose to be, part of your study or survey. They aren't randomly picked. And then finding volunteers can be a task. Imagine posting on Instagram or Facebook asking for help. In research, they use social media ads to find people. These ads can target specific groups based on where they live and how much they earn, what job they do, their age, and also their gender, education, or even what they are into, right? And the ad actually has some information about the study and a link to survey, and people who are interested, what they click the link and fill out the survey. Simple, right? And the methods can touch people globally also, but how many you reach depends on your ad budget or all this stuff, right? Sometimes you might get a response from people you didn't even target, and the result might not represent everyone. Mostly you'll get response from folks who are really into the topic. Like imagine American Idol asking viewers to vote for their favorite singer. Only the fans will bother to vote, right? Not everyone. Anyway, next we have purposive sampling or judgment sampling, right? And this one's a bit like choosing players for a basketball team based on their skills. And in research, it's when the researcher picks people for a study because they have got something specific to contribute. And let me tell you how it works. Researchers use their know how to pick the right people for their study. It's not random, it's about finding folks who can provide the most useful insights. This method is super common in studies where you're diving deep into a topic like understanding personal experiences or when you're working with a small group. Right? The researcher needs to pick a solid game plan for choosing people. Right? They can't just randomly pick. They need to clear, the reasons for each choice. And suppose researcher wants to learn about disabled student experience at your university, they'll purposely what choose a variety of students each dealing with different challenges to get a broad picture of how student services are working out, right? And then here it comes, the most important sampling in non-probability sampling is snowball sampling. Why? Because in exam they ask question based on that also. And let me break it down for you. Right, and this technique is super handy when you're dealing with a crowd that's tough to pin down or kind of hidden from the usual ways of finding people for surveys or studies. Imagine you're trying to find out more about a group that's not easy to just walk up and just ask questions. This is where snowball sampling comes in. It's like starting with a tiny snowball and rolling into downhill to make it bigger. You begin with a few people and they help you to connect with more and so on until you have got enough folks for your study, right? And imagine there are three main flavors of sampling also. That means types of snowball sampling. First is linear snowball sampling. This, think of this as a simple straight line. You start with one person and that person leads you to another and then to another, kind of like a chain. You keep going into this straight line fashion until you have got as many people as you need for your research or for your study. Right. Next we have exponential non-discriminative snowball sampling. Quite a big name, but don't worry about it, it's easy. This one is more like branching trees than a straight line. You start with one person, but instead of just leading you to one more person, they point you to several people. Each of those folks can lead you to several more, and it grows pretty quickly. It's like each person you meet opens up a whole new bunch of possibilities. Right. Next we have exponential discriminative snowball sampling. That was non-discriminative, this was discriminative. So this method is a bit more selective. You don't just take everyone who comes along. Instead, you have a set of criteria and you screen people to make sure they fit what you're looking for before adding them to your sample. It's like having a kind of bouncer at the door for a club, checking if people meet the dress code, right? And let me give you the example, then you'll understand. And say a researcher wants to understand what it's like to be homeless in a city. There's no easy list of all the homeless people out there, right? So traditional ways of picking a sample won't work. The researcher finds one person who's willing to take part in the study and asks them to introduce other homeless people they know. This way, the researcher can build up a group of participants, like starting with one snowflake and ending up with a whole, snowball. And this method is super useful when you're studying groups that are hard to reach or not well represented in usual data sources. It's not perfect. There is a chance of bias since you're relying on people's network. But when you're dealing with hidden or hard to reach population, it can be a real lifesaver. Right. So we have next is Minimax sampling, Line-Intercept sampling, and Penal sampling. We will talk about one by one. So sometime in Minimax sampling, sometime we have a bunch of data, right? But it's not very fair. Minimax sampling is like a superhero fixture in this situation. Imagine if we have more of one thing and less of another in our data. That's what we mean imbalanced data set. Now what this method does is it helps us to take a fair sample even if our sample size doesn't match the real. Next is line-intercept sampling and or sampling with lines. So this one is like a game of drawing lines on a map. Imagine you have a map of place and you want to pick some spots to study. Instead of randomly pick, we use a pencil line called transact. If this line crosses an area, we'll check out what's in that area. It's like drawing a line and saying let's see what's on this line. Next we have panel sampling, and this panel sampling is kind of repeating interviews for super knowledge. Now let me tell you, this is quite interesting. Panel sampling is like when you have a group of friends and you want to know what they think about something, but you don't just ask them once, right? You keep coming back to them at different times. It's like having a chat with your buddies multiple times to see how their thoughts change. Each time you talk to them, it's called a wave, right? This cool method was created by a sociologist named Paul Lazarsfeld in 1938. He used it to study political campaign, so it's a smart way to learn about stuff over time. So guys, that was all about your sampling. We talked about probability sampling and its type. We also talked about non-probability sampling and its type. Now it's time to understand the sampling error. And when we conduct survey or research, we are almost like always going to run into some kind of error. It's natural, it happens, right? And it's like trying to take a perfect photo. There's always something a little off, right? Now in the world of surveys, we can generally put these errors into the big bucket like sampling errors or non-sampling errors, right? And think of them as two different types of photo blurs, each when it's on cards, right? Now it has some types also. One is sampling error and bias. Now let me tell you, imagine you're trying to take a group photo, but only some people show up. That's a kind of what happens here also. These errors pop up because of the way we pick who's going to be in our survey. Next is this is only the folks who love the camera jumping into the photo. In survey, it's when only certain types of people end up responding, which can kind of ruin the result, right? And we have like random sampling error. Even if you randomly choose people for your group photo, each shot might look a bit different, right? Similarly, in survey, random selection can lead to variation in result. Next, we have non-sampling errors. So these are like the other photo mishaps, right? Someone blinks or the camera blurs or the lighting's off. They aren't about who's in the photo but how the photo is taken, right? So this is a kind of non-sampling error. Let me tell you, it has also some types like over coverage. Imagine accidentally including people from a different party in your photo, right? In surveys, it's when data comes from outside your target. That is your over coverage. In simple, what data collected from population outside of the sample. The second is under coverage. The sampling frame does not include all elements of the population, right? So it's a kind of opposite problem. Missing some key friends in your photo. It's when the survey misses parts of the population. Next is measurement error. And this error occurs when respondents do not understand the question or cannot answer it, right? Like asking someone to smile but they frown because they misunderstood, right? In surveys, it's when people don't get the question. Next, we have processing error, and this is a kind of mistakes in data coding, right? And this is like to messing up while editing the photo. In surveys, it's about errors in handling the data, right? Next, we have like non-response or participation bias. It is kind of failure to obtain complete data from all selected individual, right? Think of this as some people refusing to be in the photo. It's when selected folks don't respond to the survey, right? And again, let's talk about other types of sampling error, like a population specification error, Imagine you're supposed to photograph seniors but end up with juniors. So in survey, it's when the survey targets the wrong group, right? A population specification error occurs when researchers don't know precisely who to survey. And the last one is sample frame error. So the sampling frame errors arise when researchers targets the subpopulation wrongly while selecting the sample. It's similar to the population specification error, but it's more about picking the wrong subset of a group for your photo, like only photographing the basketball team when you wanted a variety of athletes, right? And that was all about sampling, guys. I hope you understand its type, and imagine one question is like 100% that you are going to get in your exam. And remember, in our next session we're going to talk about data collection and data analysis. We'll also talk about data analysis tools and all these stuff. Anyway, thank you so much, and I'll see you in our next session. Bye bye and have a good day.